So we're going to continue on with our exploration of how to solve inequalities. Here we're going to talk about how we're going to solve problems with multiplication involved in them, and also division as well. So let's look at this and see. The multiplication property of inequalities states that multiplying each side of an inequality by a positive number produces an equivalent inequality. So if we have here 5 is greater than 3, and we multiply both sides by, well, let's say by 10, we still end up with a true statement. That's what that means. So 50 is greater than 30. Great. Makes perfect sense. However, this is the part where it gets a little bit harder, and we're going to show an example just to make sure it makes sense. Multiplying each side of an inequality by a negative number reverses the direction of the inequality symbol, producing an equivalent inequality. So if we look here, if we have here 5 is greater than 3, and we multiply both sides by negative 10, what we have here is we have 50, or negative 50, and negative 30. So now we have to change the direction of the inequality. Whenever you multiply or divide by a negative number when solving for an inequality, that's the thing that you need to make sure to do. So really important. And one of the easiest ways of checking this is by plugging in an answer and seeing if you're right after you solve for the inequality. So the division property, same thing. It just it's exactly the same way. It's just if you divide to solve for a problem by a negative number or by a positive number, then you're going to end up with let's see, if we have 10 is greater than 2 and we divide both sides by 2, you end up with 5 is greater than 1, which makes perfect sense. However, if you do it this way, 10 is greater than 2 and you divide both sides by negative 2, then all of a sudden, that's negative 2, all of a sudden you end up with negative 5, and over here you end up with negative 1, and you've got to flip the inequality symbol. So that's what these examples are going over. So let's look at this. It says here, solve negative 18y is less than 72. So what we're going to have to do is we're going to have to divide both sides by negative 18. When we do that, we end up with, let's see. So I rewrote it over here, and what you're going to end up with is if you divide both sides by negative 18, you're going to end up with y is and something to negative 4. And the really important thing is, since you're dividing by a negative number, it's going to be this way. Checking your answers is key. Going ahead and plugging this, like take a value. I always like to use 0 because it's the easiest one to work with. If I plug 0 into, if I say y, let's see if this works for y is equal to 0. If that's the case, is 0 greater than negative 4? Yes, it is. So if I plug 0 into this equation, it should work. Negative 18 times 0. That's going to be 0. Is 0 less than 72? Yes, it is. So therefore, I know I have the inequality solved correctly because I flipped that sign. So we're going to look at a couple more examples here. It says, so it says here, on average, a customer service representative helps at most 160 customers during an 8-hour workday. Write and solve an inequality to find the average number of customers she can help each hour during one of her workdays. Okay, well, so 160 is going to be the most she could help. So anything is going to be less than or equal to 160. And so an 8-hour workday, so it's going to be 8 times C. We're going to divide both sides by 8, and we end up with 20 is less than or equal to C. So that would be the most that she could help if you were expecting on average during one of her workdays. So looking at this example here, we got 14x is greater than or equal to negative 56. So we're going to divide both sides by 14. So I rewrote it out here. We're just going to divide both sides by 14, so we end up with just x is greater than or equal to negative 4. So remember that it has to be a filled in circle here. And then what we're trying to figure out is, are we going left or right? x is greater than or equal to -4, so it's going to be this way. Let's do the quick check. Let's plug in 0 into the original equation to see if we're right. We plug in 0 there. 14 times 0 is going to be 0. 0 is greater than or equal to -56, so I know I'm on the right track. So now I've set up this next problem here. It says here, x divided by -3 is less than 9. So what I have to do is I have to divide both sides by -3, and when I do that, I end up with x is, and I have to flip the sign, flip the inequality, x is greater than -3. So I'm going to have an open circle, because -3 is not a solution. And then x is greater than -3, so it should head that way. And I'm going to plug in, again, I'm going to plug in 0, because it's the easiest one to work with. 0 into the original equation. 0 divided by -3 is 0. 0 is less than 9, so I know I'm heading in the right direction. For this next problem here, write the following verbal sentence as an inequality, then solve the inequality. 6 times a number is no more than 96. So 6 times a number, I'm going to use the value p, is no more, so it's less than or equal to -96. So that's a way of looking at it when it describes numbers like that. And then we would just solve it, dividing 6 into both sides. We'd end up with p is less than or equal to, I believe it's 16, or -16, excuse me. So looking here is, if we were to plug in this here, we'll rewrite this to make sure it's easy to understand. So in this problem listed here, it says, is -3 a solution of, and then it's 6 plus 4x is greater than or equal to 7x plus 11. So I can just plug in -3 into these different parts and see if it's a solution. -3 there and -3 there. So it's going to be 6 to see if it's a solution. -3 times 4 is going to be -12. Is that greater than or equal to? -3 times 7 is going to be -21. And then I just do the addition on both sides. So it's going to be 6 plus -12, so that's -6. Is that greater than or equal to -21 plus 11, so that's -10. So that is a true statement, so yes, it is a solution, so yes. Solve the inequality, then graph your solution. Okay, so here we're combining the two parts here. We're combining the adding and subtracting, and then we're also combining the division and multiplication. So let's set this up. And it's the same rule. It's easier to get rid of the addition and subtraction part first. So that's why I'm subtracting 2 from both sides. They end up with 3x is greater than or equal to 33. Now we're going to divide both sides by 3. When I divide both sides by 3, I end up with x is greater than or equal to 11. So then I've just got to figure out where my 11 is, and I'll plot from there. Okay, so I just went ahead and I wrote out the even numbers, and so obviously 11 is going to be right there. I have to color in the circle because it's x is greater than or equal to 11, and then I'm heading that way. I'm going to plug 0 into the original equation to see if it's right that 0 is not a solution. So 2 plus 3 times 0 is just going to be 2. 2 is not greater than 35, so I know it's not a solution. Now I'm going to set up this other problem here. So I set this up, and now the important thing to recognize about this problem here is that when you subtract m divided by 3, that's like negative m divided by 3, so we're going to multiply both sides by -3. And when we do, we end up with -9. And we need to flip the sign because we multiply by a negative number. So that's going to be our solution. And then we check it by plugging in 0 again. And if 0 is in the original one, we'll see if that's a solution or not.